Hello everyone. Talking about area of minor segment of a circle. I should say of the minor segment of a circle. Anyway, you notice here there's a diagram of a circle, and ignore the sort of radius and stuff. The red highlighted part is cut off by a chord. A chord is this line here. A chord is a line that connects any 2 points on the circumference. This is a segment, right? A sector is like a piece of cake. A segment is if you just randomly cut a cake and everyone will get annoyed at you at the party because you just cut it up wrong. So you get a minor segment and a major segment. We're focusing on the minor segment because there's a particular way that we view it. You cut it off using the 2 radius, and then you see there's a triangle, and then there's this little area left. And basically that's the way we find the area. So it's the difference in area between the sector and the triangle. So it's a little bit messy, but basically the segment here is the part that's left if you have the sector, which is like the piece of pie, that you then cut off the curved bit, and you're left with a triangle and this little curvy bit. And so we find the area like that. The area of the sector, as we found out before, was half r squared theta. And then the area of a triangle, by using half AB sine C, it's half times r times sine theta, which is half r squared sine theta. Now, if I find the difference in those, I subtract half r squared theta minus half r squared sine theta, and you get the thing in the red box. A is equal to half r squared outside of theta minus sine theta. And again, you have to have theta in radians. This is, otherwise it does not work. Degrees, you have to do conversions for, etc. Okay, now again, if we were to just do some couple of examples, we're going to do the first one. Find the exact area of the minor segment if the radius is 3 meters and the angle subtended is 2 pi on 3. Let's say it again. 2 pi on 3 is equal to how many degrees? Well, we always multiply by 180 over pi, and it ends up being 120 degrees. All right? So again, I want to draw a diagram. So what we're saying essentially is, if I get my circle here, and I draw about, that's not quite the center, but if I draw about 120 degrees, it will look something like this. It's 2 pi on 3. And what we want to find is if I connect this up, that's the area I want to find, the segment. All right, so the radius is 3 meters. It's quite a big circle. So how do I do it? Now, it says exact. If you're underlining this, you'd need to do the exact area. The temptation would be to put it as a decimal. We want the exact area. So A is equal to, remember, it's half r squared theta minus sine theta. Okay, so we're going to have half times 3 squared outside of 2 pi on 3 minus sine of 2 pi on 3. Now, 2 pi on 3 is in the second quadrant. Sine 120. Sine 60 is root 3 on 2. So therefore, this becomes 9 on 2, I wrote 3 as I meant 2, 9 on 2 outside of 2 pi on 3 minus sine of 2 pi on 3, second quadrant, so sine would be positive, sine 120 degrees, that's still the same, is root 3 on 2, because it's related to sine 60, which is root 3 on 2. And that is the exact answer. Now I could sort of neaten it up a little bit, which becomes 9 on 2, it's going to be 4 pi minus 3 root 3 over 6. There's a common factor of 3 here, so I'm left with 2. 3 outside of 4 pi minus 3 root 3 over 4 is what it becomes. And it would be square meters. Now, that's not a particularly useful exact area, but you do need to know how to manipulate pi and square roots and things like that. But that's the way we do it, right? So it's just a direct application of the formula. Now, if you have a look at the next example, the area of the minor segment cut off by an angle of 2 pi on 9 is 500 square centimeters. Find the radius of the circle to 1 decimal place. Okay, so again, if you don't draw a diagram, you're just causing yourself probably some difficulty. And we've got to be clear on the angle. 2 pi on 9 is equal to, well, we multiply it by 180 on pi. Pi goes away. So that's actually 40 degrees. 180 divided by 9 is 20. 20 times 2 is 40. So it's about 40 degrees. So basically what you have is, we've got 40 degrees in here. I'll write it into radians because we're working in radians now. 2 pi on 9. And the area of the minor segment, so it's got to be quite a big circle, I think. So that area there is 500 square centimeters. And R we don't know. So, again, I'll write the formula. A is equal to half R squared theta minus sine theta. So in this case, we know what the A is. It's 500. Half R squared. Well, I know what theta is as well, which is 2 pi on 9 minus sine of 2 pi on 9. Now, in this case, we don't know sine 2 pi on 9. Well, it doesn't have an exact ratio. You've got to multiply everything by 2 as the first step. And then I'm going to estimate what's in the bracket. So we're going to actually find that. 2 pi on 9, 2 pi over 9 minus sine of 2 pi over 9. Now we've got to remember here that your calculator has to be in radians. Otherwise it's not going to work. So 0.05534. Right? So I simply now have to, R squared is equal to 1000 divided by that. I get 18,068.7762 and we square root. R is equal to 134.4 centimeters. Now, because it's in square centimeters, I'm going to leave my answer in centimeters. He may have asked me to find it. It's a pretty big circle, but may have asked me to do that. But that's to 1 decimal place. So again, it's using the formula. When you know certain information but don't know others, you just have to do a rearranging. Also remembering that if you don't know an exact ratio for a sine, well, for sine or something, there's only a few, you'd have to do a decimal approximation. Okay, so have a go at that. We're doing exercise 6.4. There's some instructions in Canvas as well. Sorry, there's one more question. Oh, the length of an arc is 8.9 centimeters and the area of the sector is 24.3 centimeters squared. When an angle of theta is subtended at the center of a circle, find the area of the minor segment cut off by theta, correct to 1 decimal place. All right, well, this has got a lot going on. So I'm going to draw a nice size diagram. So we have an arc of 8.9 centimeters. 0.9 centimeters. So we've got to be clear on what the definitions of each thing are. I think we believe that we're going to want to find this area. So that's what we're looking for. I'll put that as a question mark. Now I'm going to do in green, the sector sort of overlaps is 24.3 square centimeters. Now, the angle in the middle is theta, and we also don't know what r is. But we're given two things, which is going to allow us to find r and theta. So r equals question mark, theta equals question mark. We need both of those to work out what the minor segment is. So we do know, however, that L is equal to r theta, and A for the sector is half r squared theta. So what do we know? Well, we know that. If I take this over here, 8.9 equals r theta, and 24.3 equals half r squared theta as well. Now, we might as well kind of get one thing or the other and make it the subject. So we're going to have to substitute one into the other anyway. So we're going to do some work on that. So equation 1, let's sub in theta. So theta is equal to 8.9 over r. All right, we're dividing by r on both sides. Substitute into number 2. So 24.3 is equal to half r squared times, instead of theta I now put 8.9 over r. Okay, I'm going to multiply by 2, which gives us 48.6 on this side. One of the r's divides out, which is 8.9r I'm left with. So r is equal to 48.6 divided by 8.9, and that gives me 5.461. We're in centimeters, right? So therefore, theta is equal to 8.9 over 5.461, which is radians, and that's equal to 8.9 divided by the answer, 1.630. And that's radians. Okay, so now I've got that. Now I can find the area of the segment. Now find area of minor segment, which is simply A is equal to half times r squared, which is 5.461, times 1.630 minus sine of 1.630. And if we work all that out, 0.5 times, it's half r squared, isn't it? 5.461 squared times bracket 1.630 minus sine of 1.630 equals, and I get 9.4202. It's asking for one decimal place, and hence why I've given it to 3 decimal places up to now, so 9.4 square centimeters, keeping track of the fact that this is an area. The radius is a distance, so it's centimeters, radians, theta is an angle with radians. Okay, now we can have a go. Exercise 6.4. Thanks.